Hey y'all, it's Andrew Couch here. In this Tidy Tuesday video, we're going to be using the Plumber package to deploy Tidymodels and use it in Excel. So I was playing around with a Plumber package a few days ago, and I thought it was pretty cool because I was using an XGBoost model in an Excel workbook, and I think it's a pretty useful thing that you could use in your own work. So what the Plumber package does is it essentially creates a web API. So you can just create a function to use your model and then deploy it by using a API request. What's also cool is that you can host it on your local browser, or you can actually deploy it somewhere else, say using AWS or whatever. So we're going to be using the Plumber Penguins dataset. I really like it, and I think it'll be kind of the replacement to Iris. So we're first going to make a model. So I'm going to call this Tidy Tuesday. What is it? Tidy model. Let's just say Excel models. Because we're going to make a model just for Excel. Okay. So I'm going to load in the Tidyverse, Tidymodels, and the Plumber Penguins package. Okay, and then using the Plumber Penguins package, we're just gonna grab the data set, which will be penguins. And if we look at, our penguins data set, and if we look at our penguins data set, we can see that there's some missing values. Additionally, since what we're gonna do is basically predict the species, we're gonna count the species. So there's 3 species that are a little bit imbalanced, so we might have to fix something there. I'm just gonna look at the summary. So we have a few missing values. I'm fine with basically removing these missing values. So I'm gonna do df drop missing values df. Okay. So first we're gonna do the modeling process. So I'm gonna say I'm gonna start doing the modeling. So we're gonna do our train and test splits. So create train and test sets. So I'm going to do an initial split. df prop will equal to 80, so 80-20 split. I'm also going to stratify based off the species. I'm going to call this tidy split. Oh, actually, I'm going to set the seed to the 15th, so do that. Okay, and then I'm going to make a train data. So training, test data, testing, and then I'm going to make our k folds data, which will be v fold cv, and we'll give it our train data. Okay, so then we're going to start our pre-processing. And with our pre-processing, sorry about that, we're going to first do a recipe. We're going to predict species using our training data. And I'm just going to do a basic pre-processing. So I'm going to do a step normalize, and it'll be all numeric. I'm going to do a step dummy, all nominal minus all outcomes. I can also do a downsample if I want to, and specify, say, the actual class that we want to predict to even out the set. So if we do this, let's see if it does that. We can see it's centering and scaling for these numerical data, creating dummy variables for island and sex, and then downsampling based off species. And if we look at our actual length, we have 333. So that's that might be a little suspect for doing downsampling. However, this is just a basic toy data set, and I'm actually gonna just leave it as is. So this is always an option. So I'm gonna say right here, say can account for class imbalance if you want. Okay. So I'm gonna just call this the tidy rec. Okay, so now let's create the models. We're gonna create a XGBoost model. So XGBoost model and then boost tree. For the tuning, I actually just want to tune, let's just say, trees and tree depth. Just only 2 parameters. It'll be a it'll be a set mode to classification. XGBoost handles multi-class classification, so that's fine. And we'll set our engine to XGBoost. Also throw in a logistic regression. So I'll just say logistic model. In this case, it's a multinomial regression, but we'll say the penalty is equal to tune and our mixture is equal to 1. So it's like a multinomial lasso regression. So set mode to classification and then set the engine to GLM-net. We have 2 models that we're going to be using. We'll create our create tune grids. So in this case, what I'll do is I'll just do an XGBoost grid regular, give it the XGBoost model parameters. And I'll only specify about, let's say, 3 sets. So it should be about, what is it, 6 or 9? Yeah, 2 to the third. Wait, yeah, 2 to the third power. 3 to the second power, I mean. And then what I'll do is I'll create also a logistic grid. So logistic grid regular parameters. Oops. And then we'll give it the logistic model, and we'll say that we'll use 5 levels just because it's pretty easy. Additionally, I'll set the metrics. So I'll say model metric, and then metric sets. We'll just use, say, accuracy, ROC, AOC, and then mean log loss. Pretty straightforward metrics. We'll use accuracy just on predictive power, and since we have a little bit of a cost imbalance, we'll also look at the ROC, AOC score. And then mean log loss is always a good metric to use just to test your model certainty. Okay, now let's actually just tune the model. So tune models. I'll say XGBoost res, tune grid, give it our XGBoost model, our tidy recipe, our grid, which will be XGBoost grid, our resamples, which will be our k-folds data, and then our metrics, which will be our model metrics. And then I'll create a logistic res and do the same thing, where I'll probably just paste this in. And I'll switch this to logistic model, right? Logistic model, and then logistic grid. Okay, so then we're just gonna run that, and while it's running, I'm actually gonna open up my desktop. I'm gonna go to my Tidy Tuesday project, and I'm gonna actually create a folder, and it'll be a Tidy Tuesday Excel model, and this is where our Excel models will be living in. Let's see here. I might also just start the Plumber API. So while it's training, we'll just create our Plumber API. In this case, we'll just create a new one, and we'll say what, Excel model, and then I'm gonna put that in my Tidy Tuesday place, and then I'll put it in, where's the Tidy Tuesday Excel model. So right there. Okay. So I can see that our models have finished. So I could just look at our results. So evaluate models, XGBoost res, collect metrics, and then we'll say summarize equals false. Okay, and then we'll look at our logistic res, collect metrics, summarize equals false. Okay. We'll bind the rows together. Okay, and now let's actually plot it out. So ggplot Oops, actually, I need a model. I need to call this a model. So I'm going to say mutate model is equal to XGBoost. And then I'll mutate model is equal to logistic. Okay. So now we have a table of all of our tuning grid results. So now I'm going to say x equals model, y equals dot estimates, gm column, and we'll facet wrap by the dot metric. Scales is equal to free just because they're on different ranges and axes. Okay. Oops. Let's see here. Actually, we'll do a geom box plot. There we go. So what do we see here? Basically, these models are very similar. So just evaluating ROC, AOC, we can see that they have near perfect ROC, AOC scores. We can see there's one outlier with the logistic regression where it's essentially just randomly guessing, and that's kind of a red flag to me. Additionally, our log loss, the logistic regression definitely has a lower log loss, however, has a lot of outliers. And then finally, if we look to our accuracy, we can see that our XGBoost model just has better accuracy in general. Obviously, there's an outlier right here outside of logistic regression's box plots or quartiles. However, logistic regression has a lot of outliers that are very low on the bottom. So this is something we'd kind of expect. I would expect XGBoost model would probably do a little bit better than logistic regression. Additionally, we didn't do anything to really pre-process it, so I'm sure these things are highly correlated, which could be done where we could have fixed that with like a PCA or just did some manual feature selection, but that's fine. Because ultimately, I think an XGBoost model in the video for Excel is definitely more clickbaity, and I think more people would click on it, so I am fine with doing XGBoost model. So we're going to extract the results. So XGBoost res, we'll do a show best. Then I'll just do it on ROC AOC. So we can see how there's some ties, right? So if we're going right here, these two models are very similar. If these are the same, I'm just going to go with a simpler model. And in this case, we can see our tree depths are the same. Tree depth is the same. And then we can see our trees are a little bit different. So I think more trees offers a more robust analysis, I believe. So I'm just going to go with the 2000 trees. So I'll just say slice 2. Okay, great. So now I'll just do a finalize model. Give it our XGBoost model. I believe that's how it goes with trees. I'm actually not too sure. I might have to research that up. My intuition is that trees are the same kind of thing as neighbors, where with the nearest neighbor model, you generally want more neighbors for a more robust estimate. So I figured more trees would be a more robust estimate. I'm just kind of spitballing, but that's just my own intuition to it. Okay, so we're gonna finalize our model, give it our XGBoost model. Right, so if we look at our XGBoost boost model, you can see we have 2000 trees with a tree depth of 1. Very straightforward. Okay, so now what we're going to do is create our final model. Okay, with our XGBoost model, I'm actually going to create a workflow so that way it can do the pre-processing for us. So I'm going to say model. I'll just say final model workflow, add model, which is our XGBoost model, add recipe, which will be our tidy rec. And then what we're going to do is get our last fit. So I'll say last fit, final model, and then we'll give it our initial, or our tidy, what is it, tidy split. And then I'll do collect metrics. Okay, and what do we see here is it has 100% accuracy, has not seen that data, and it fit it perfectly. So this is like very good results. There might be probably duplicates in the data set where it's just like similar penguins, but it technically did not see it, and I'm feeling very good about it. So finally, what we're gonna do is fit our model. So final model, we'll do final model fit to our data set. Okay, and now I'm gonna save this model, final model, and I'll say Excel model.rds. What I'm also gonna do is I'm gonna write the penguin CSV. So write CSV penguins, and I'll call it penguins.csv2. So this is our modeling. In this, I'm gonna save this into our Tidy Tuesday Excel model, and I'll say Tidy Tuesday Excel model. Sure. Yep, Excel model. I'm gonna go to my directory. We have that. I believe I need to save the penguins, so I'm gonna move this penguins dataset to our folder. Where is it? Tidy Tuesday. Let's see here. Where is it? Excel model. All right. Great. So now we have our actual. Wait. Oops. Where's our model at? Oh, there it is. So we have that, and then we can go to Excel model. I can throw this in. So we have a model, and now we're gonna start making our API. Okay. I'm gonna delete that. I'm gonna set my working directory to the Tidy Tuesday Excel model. Where is that at? There you go. There we go. And there we go. Okay. So this is a Plumber API. They give you a little hello world, same thing as our Shiny. If I run it, it'll start running the API, and now we have it in my browser. It comes with this cool little like interface, so I can do like get. You can try it out. If I message like hello world, it'll execute, and then I'll say this message is hello world, and you can actually see what it's doing. So it's saying, it's through curl, it's saying like get. It shows the IP address or wherever that you're hosting it on. It shows the command echo, and then the parameters. Okay, so that's pretty cool. And what we're gonna do is basically do this same thing in a model function. Cool. So I'm just gonna rename this title. I'll say Excel model. Also, I'm gonna read our model. So I'll say model is read RDS, and it's called Excel model.rds. So now I have this large model workflow, right? If we actually look at what is it, our model fits, and then we go our, what is it? Handling, okay. Trying to find what our data is, but that's fine. We can just call it the, we can just call in the Plumber Penguins dataset. Penguins, okay. So what we need to do is basically write out this function to call it in Excel. So I'll say classifies penguins. We can also do, what is it? So species, and then we can do so we have our species, and I'll just say classifies penguins like Adelie, Gen 2, and chin strap. Okay. So now what we're going to do is write out the parameters. And if we look at our parameters, so call names. Oops, how am I going to do this? If we do this, we can look at our column names. So let's start writing out the parameters. So our first parameter will be island. And I'll just say island penguin lives on, and I'm just going to give it the name. So Torgerson. Let me do a view of this. So we have Torgerson, Bisco. So Bisco. What else we have? And then Dream. Okay. And Dream. We're gonna enter another parameter. So luckily it has all these little helpers. We'll do like bill length millimeters, and it's just like penguin bill length. Then we'll do it at param. Was it bill depth millimeters? And we'll say bill penguin bill depth. Make another parameter. Flipper length and we'll say penguin flipper length. So I'm just gonna fill all these out, which is a little. It's a little. I feel like there's a fast way to do this. I'm not sure how to. Maybe there's a package that'll make it easier, but this is kind of how I've been doing it. It also kind of gives you a chance to explain the parameters. In this case, it's pretty self-explanatory, but it might get more confusing if you have a more a harder problem that requires a little bit more domain knowledge. Okay, and then let's do sex, penguins, sex, male, female. Okay. So now we have this. What we can do is make our actual tibble or put it into our function. So in this case, I'm going to do a island bill length in millimeters, bill depth in millimeters, flipper length in millimeters, and then body mass in grams, and then sex. I'm also going to copy this. So what we'll make is a little tibble. Okay, I'm just gonna do this. So we have our island is equal to island, and I'll do as dot factor island. Bill length is equal to bill length, and this will be as dot numeric. Let's copy this again. It's equal to that, and this is as dot numeric. Our flipper length is again another as dot numeric. I think you could probably do a tidy eval, but I'm just gonna hard code it in just to make sure I didn't mess anything up. So as dot numeric, and then sex is equal to sex as dot factor. Okay. One thing when you're doing with functions in an API is it's basically you're gonna have to specify the library. So in this case, it's dplyr or tibble. And then finally, what we can do is our predict. So we're gonna say we can just say our model data is that, and then our results or what's gonna output is we're gonna predict using our model data. Okay. I'm actually going to load in the tidyverse, so library tidyverse. And with our model, if we actually do our little prediction right here, so for example, if we say I predict Palmer penguins, okay, so if we do our Palmer penguins, right, and we say a slice like 1. And we give it a prediction. So if you say predict model and give it the Palmer penguins, it'll give us our .pred class. But it's giving it in a tibble. So what you have to do is actually pluck it. So that way it's actually returning the actual value. That's what we're going to do. So we'll say pluck 1. We'll say per. I believe pluck is from the per package, right? Pluck is from per. So we have that. Okay, so let's just, I'm gonna save this. And let's run the API and see if it works. Okay, so now we have our get. Ooh, actually I should change this. So get, we're gonna rename this to like predict. Okay, so now we have our function. We renamed our function to predict. So get predict classifies penguins, Italy, Gentoo, and Chinstrap. we actually try this out in here. So we'll see island, we'll say Bisco, like 150, 150, 151, I guess, 150, 1800, and we'll say like male. See if it works. It runs into an error. Let's see here. What's going on here? And then boom. Got a little colon. So let's run it again. Get, I'll just try it out. Bisco, 150, 150, 150, which is 1800, and then male. And then it predicts the actual class. So that's cool. So now that we have our Plumber API, let's actually go in and run this API and put it in Excel. So I'm going to open up this Excel worksheet. Okay, so we're dealing with missing values right now. It's definitely possible for us to we could have added into our model how to deal with missing values, but for now I'm just going to work this model onto a sheet with no missing values. Okay, so first let's actually run our API again. And then if we look at our get, if we type in if you try this out and say 123 123, male, I'll do Bisco. We can get this little query. So since our API is running right now, we can actually just query this website using Excel. And then if you look at it, it says island equals blank, bill length equals blank. We can basically swap those values with an Excel value. So let's go. We can notice that this thing is still running. If we go here, what I like to do is paste this, which is paste it. I also like to do a little insert a row. And what we can see here is, okay, this is our main function, our main little link that we want to use. So I'll just copy that, put that right there. And now we can see we can kind of see the pattern of this, where it's saying like island equals this, and then you have an ampersand sign or and sign. So what we can do is just do a little concatenate. This is an equal, right? And then we'll do the same thing, except we want to add a and sign because we're doing multiple commands. And we'll just bring it up over there. Okay, so now we have parts of our API request. And here is what we can do is concatenate all of it. So this one, we'll put this. So I'm pressing F4 whenever I press on these column field names. So whenever I drag down, it won't change the location. And then I'm fine with these actual values with changing the location. Cool. So now we have this link. I forgot this other one, so I'm going to concatenate this part. And now we have a link. What we can actually do now is wrap this with web service. And what it's doing is it's basically kind of accessing this website and getting whatever is the result. And what we can see here is it used our API, given the input data from our Excel our sheet, and use our XGBoost model to predict the species. Okay. And now you can see that, you know, when there's a tie, it'll just it'll do 2, but we can see how our model is working as we would expect it. I actually want to kind of change this to F4. There we go. And then we can do that. And we can see it's working very fine. I want to note that you can't directly use this worksheet, I think, because the IP address will change every time you run it. So I know this is a pretty quick video, but I thought it was pretty cool to be able to use an XGBoost model in Excel by creating an API. And honestly, in the future, I definitely will look more into how to make more complex API functions and also how to like deploy it to a more robust platform such as AWS or even RStudio. So I hope you guys liked the video and tidy on.